All right, introduction to computers. We're just about done with all the notes. This is actually week 15. I didn't write it on there. This is Tuesday. I have a Tuesday-Thursday class. We reviewed this whole idea of that WF stands for workforce, by the way. And we have all this huge data. We figure out what data has value. We convert the data into something that has value, which we refer to as information, and we use that information to make decisions. Some of the decisions are very structured, in which computers can help us make the decisions. Some are more non-structured, which there's more of a human influence. And that is slowly changing with time. We talked about some of the things inside automobiles. Cars can gather up data to help them make decisions in terms of how to park, if they're crossing over the middle line, etc., etc. And we talked about the Google Smart Car a little bit today. I reviewed some of this, development of information system, that whole idea of life cycle, starting out, growing, developing, becoming productive, and then eventually dying in that life cycle. We talked about top-down design, and I didn't talk about bottom-up, but I will briefly, and we'll talk about that the next time we meet. The whole idea, you define the problem, you do investigation, you make sure you understand the problem, and then you do an analysis. And then design a solution. Those are critical. You don't want to start developing a solution until you've done all of those in most situations. Now on Thursday we'll talk briefly about bottom-up design to where you might not do it that way. Once you are sure this is what you want to do and so forth, then you go into that development. That's where you start purchasing hardware, looking at how you're going to get the software to do what you want it to do, and how you're going to train people and so forth. All three are critical. Once you get it developed and tested and it's up and running, then you can implement it. You can do a pilot in which you just implement it like in one store or one location and see how it works. You can phase it in different parts. Maybe you do the payroll first and then phase in another part of the accounting and so forth. Some cases you can do a parallel in which you run your old system and the new system at the same time. Probably the most expensive, but the most reliable, because then you can see if the new system is working well compared to the old system. A direct cutover, in some cases you have to just leave the old system and go to the new one. It might be the least expensive, but it's the most risky. Because if something doesn't work, it has to be fixed right now. Once we get it implemented, it's very important to evaluate it, make sure it's working. Somewhere's up here in the analysis phase, you should have done a cost-benefit analysis. Is spending all this money, is that going to pay off or not? So down here, then you can evaluate. And then maintenance. There'll be things that don't work quite right. You're not, you want to change, adjust. You have some issues, and so then that's just like updating software. So you go back up to the top, you investigate your issue, you analyze it, what to do, design a solution, develop the solution, implement the solution, and then evaluate if it doesn't actually correct what you want to correct. Now, during this development phase, we have this whole idea of getting hardware, software, and training and getting the people prepared. Okay? Software, we talked about buying software. You can buy maybe an office package and design it to do what you want. Just an example, maybe buying accounting software like QuickBooks. These would be for small situations, or you can buy a package that was developed by some software company, and sometimes they'll allow you to customize it. It could be something like WebAdvisor here at the college. We bought that software and then we're allowed to customize it and adjust it to match the needs here at the college. Now, if there's no software out there that you want or would work, or you want to build a competitive advantage within your company, you might have somebody write the software to do what you want to do. For example, Facebook, they design all their own software. Team Quest, they design software. That's what they do for a living. And then they sell those packages to people to do what they want them to do. Writing it's extremely expensive. Okay, designing your own software is expensive, but in some cases it gives you just what you want, plus it might build a competitive advantage for your particular company. When we write software, we're programming. Okay, the whole idea of programming, first thing, you have a purpose, something you want to solve a particular problem, you have some reason to design software to do something, and then we have these steps. You have to define and understand the problem, write specifications for that problem, and then design the approach to the software. Once you get the design done, that's flow charts and data flow diagrams and so forth. So you understand what it is that the software has to do, then eventually you can start writing the code. So when they talk about software people coding, that's what they do. They're writing code, usually in some programming language. It'd have to be in some programming language. And we'll come back to this little excerpt over here. That code then is compiled, and then then the object code is linked, and you end up with executable code that actually runs on some particular operating system. So once you get done coding, you test the code, everything should be documented, and then you have to figure out how you're going to maintain the software. Simple example, all of us have computers probably that somewhere along the line we've got a message or it automatically does updates to our software from the company that created the software. That's this whole idea of maintenance. They go back, they notice problems, respecify it, design a solution, code it, test it, and then push it out through the internet to your computer. When they do that, when computer programmers write source code, they write it in a particular language, like Fortran, Cobalt, those are old ones, RPG. More current ones would be Python, PHP, Java, Java scripting, and so forth, C, C++, C#, and so forth. There are numerous languages. Well, those, you write it, and that's in what we would call a human form. Then it's compiled, using some software, compiles it to match a particular OS, and then it becomes an object code, which is then linked with other objects, and becomes an executable. And the executable is software that will run on a particular operating system. Whether it's with the new iOS from Apple, or if it's the Android, or if it's Windows 7 or Linux or whatever. It's designed to run on a particular operating system. So, source code. Scripts. Scripts are in the form of the source code, and then you use some software called an interpreter that does similar to compiling, but it doesn't leave it in compiled form. It interprets the lines of code as they're executed. So we have lots of things like JavaScript in web pages and so forth, and that's executed on the fly by an interpreter when it's used. Okay, so we have scripts. Last two terms up here. When you hear the term open source, here's what they're talking about. They're saying the source code is open. Anybody can go in, see it, view it, adjust it, and change it. The concept is we can create very good software when we have lots of people working on it. Open source is often then referred to as being free, and you could think of that way because open source typically then does not allow anybody to take the source and resell it. Nobody actually owns it so they can sell it. Now when companies take their code and compile it into an executable and sell it, we would say that would be more of a proprietary software. And when they sell it, in reality they're actually leasing it. They're letting you use it. And if you hear the term decompile, that means somebody took a compiled version, the executable, converted it back to source code so they can see how it would work, which would be illegal with proprietary software. And that's it for today.